Here's problem 3124. A bolt of lightning strikes the ground 200 meters from a 100-turn coil oriented vertically and with the plane of the coil pointing toward the lightning strike. The radius of the coil is 0.8 meters and the current in the lightning bolt falls from 6.02 megaamps to 0 in 10.5 microseconds. What is the voltage induced in the coil over this time period? We're going to treat this lightning strike like one large current. So we have this current coming down like this, and if we use the right-hand rule, that means there will be a magnetic field going around that current, and in the vicinity of this coil it's going to be coming around like this. So it's coming out of the page towards you through the coil. That magnetic field is going to be equal to, at least initially, mu naught I over 2 pi r, and that's going to be 4 pi times 10 to the minus 7 for mu naught times the current, which is 6.02 times 10 to the 6 amps over 2 pi, and then the radius pretty much over that whole circle is going to be at a radius of 200 meters. So this is going to be equal to 6.02 times 10 to the minus 3 Tesla. And that will be the magnetic field at that point. The area of that loop is going to be pi r squared. That's pi times 0.8 meters squared. And that's going to be equal to 2.01 square meters. Okay. Our induced EMF, average EMF, is going to equal negative number of turns, change in flux over the change in time. Area is constant, so this negative number of turns, area, change in magnetic field over change in time. And this will be negative, how many turns? 100 turns. Area is 2.01. And our final magnetic field is 0. Our initial is 6.02 times 10 to the minus 3, all over a time of 10.5 microseconds. 10.5 times 10 to the minus 6 seconds. And that's equal to 115,276 volts. Wow. More than 100,000 volts induced in that time period by this lightning strike. This represents maybe an untapped resource of energy that we possibly could use. 115,276 volts.